remember I said that we would eventually learn some easier ways to use matrices to solve some systems of equations rather than using Gaussian elimination, which is really nothing different than regular elimination? Well, this will show you a very nifty way in which matrices are used to solve systems of equations. And this method is called Cramer's rule. Now, I wrote Cramer's rule up here, but it really doesn't mean anything to you until I show you an example of what it means. When I have a system of equations, I make one matrix for each variable plus a third denominator matrix. So here are the matrices you make. First, you have a denominator matrix, which is 2, 5, that's the x, 3, -1, that's the y's. Then you make an x matrix, which is replacing the 2 and 5 in the x column with the numbers over here, 13 and 24. And the y column remains 3 and -1. And we make a y matrix where we keep the x column the same as this matrix, and we replace the y column with 13 and 24. Then we find the determinants of each of these matrices. This is -2 minus 15, which is -17. This is -13 minus 72, which is -85. And this is 48 minus 65, which is -17. Now, how do we find x? X equals the determinant of the x matrix divided by the D matrix. So x equals -85 divided by -17, which is 5. And y equals the determinant of the y matrix, -17 divided by the denominator matrix, -17, which gives you 1. And we'll see. 10 plus 3 is 13. Very good. 25 minus 1 is 24. So we were able to find the solution simply by writing 3 matrices, finding their determinants, and then using that to calculate x and y. That was so good. Let's try another system just so you can see this happening again. Now you're wondering why I had this written there. Well, that's when we go to 3 variables. But let's stay with 2 variables again. Here's 4x minus 3y equals 0. And 2x plus y equals 10. Let's write our 3 matrices. We have a D matrix, which we're going to use as the denominator, and that's going to be 4, 2, -3, and 1. That's the matrix formed by the coefficients of the variables. And so that would be 5 minus 6, which is 4. 4 minus -6, which is 10. Then we have the x matrix. Now we're going to place the x column with 0, 10. And that gives us 0 minus -30, which is 30. And y will be the 4, 2. And now we'll replace the y column with 0, 10. And here we have 40 minus 0, which is 40. So x equals 30 over 10, which is 3. Y equals 40 over 10, which is 4. Boy, that is really smooth. The way we can solve equations, there's no thinking involved, just a lot of basic arithmetic. Multiplying numbers and adding and subtracting. And we don't have to think about what we have to cancel and writing all of that. It's just done in a very neat way. All right? Let me leave this on the board, and I'll write one to see if you can do this. We'll write this 3x minus 5y equals 19. And we'll write negative 2x plus 2y equals negative 10. See if you can use this to solve that system of equations. Press pause, work the problem, then check back. Here we have our matrices. I'm just quickly running through them. And we have 38 minus negative this is negative 10, that's no problem. 38 minus 50, which is negative 12, and then y is 3, negative 2, 19, negative 10, and that's negative 38 minus a negative 30. Did it backwards. Minus 30 minus a negative 38, which is 8. And you see that we get x equals negative 12 over negative 4, which is 3. And y equals 8 over negative 4, which is negative 2. If you got that, you did pretty well. Now I'm going to show you how to do a 3 by 3 matrix using Kramer's rule. Now, I'll be honest, I did one problem, I couldn't get the right answer no matter how I tried. I kept making mistakes. And then I did this one, I just started a new one, and it took me 4 tries before I got all the mistakes out. So, it looks like it should be easy, but you have to be really careful with your arithmetic and your positive and negative signs, and it's a lot of calculations. So, again, when you start getting into bigger matrices, sometimes it's easier to just type the matrices into the calculator and calculate the determinants there. But let's take this system. X minus 2y plus 4z equals negative 12. And 3x plus 2y minus z equals 11. And then we have x plus y plus 3z equals negative 6. All right, so our D matrix is this: 1, 3, 1, negative 2, 2, 1, 4, negative 1, 3. And if you calculate the determinant of this, that's equal to 31. You can write the numbers and calculate it. Then we create the X matrix, which replaces the X column with these numbers. So now I have negative 12, 11, negative 6, negative 2, 2, and 1. That's the Y column remains the same, and so does the Z column. Okay, so you see that? And when you do this calculation, it comes out that the determinant of this matrix is 62. So you can already see that X will equal 62 over 31, which is 2. The Y matrix and here we have 1, 3, 1, and now it's the Y column that we're replacing with negative 12, 11, and negative 6. And then the Z remains the same. And the determinant of this comes out to be 31. And so we see that Y equals 31 over 31, which is 1. And finally, the Z matrix, 1, 3, 1, negative 2, 2, 1. And now we replace negative 12, 11, and negative 6. And the determinant of this matrix is equal to negative 93. And so Z equals negative 93 over 31, which is negative 3. So if you have a calculator, I know I already told you I really like the desmos.com/matrix calculator that's available for laptops and probably other types of computers as well. So this gives you an idea of how we can use matrices in a very basic relationships to calculate the solutions of equations. It does all of the numbers and everything else that we do in the elimination, but it does it in a very organized way, and keeps all of the computations simple as we go along. Again, it's a set pattern, and anytime we have a set pattern that always leads to the solution, that's a safe way of finding the answer without mistakes.